Hi, welcome to Paultre on Power, Power Systems Design's podcast on the latest in power and power design. This is a special video edition in honor of the global media event that's going on this week. We've got companies from all around the world coming here to talk to journalists from all around the world. I'm lucky right now to be sitting with DiNardo. He's the president and CEO of Exar, and they're doing a lot of things in digital power right now, and that's a big area right now for the engineer, isn't it, Louis?
Yes, it is. Good afternoon. It's a very big area for the engineer, as well as for most customers. Every electronic system requires power management, energy conservation. The green energy plans that companies have really have a big impact on how they do power supply design.
Well, and the funny thing is that it's like everyone agrees that digital power is good. But where's the line drawn? How much digital does your system need? What have you seen in that space, in that question?
Well, it's interesting. I think, frankly, it has less to do with digital versus analog power. At the end of the day, power is analog. You deliver voltage, you deliver current. What we're really talking about is how the system interfaces with the power supply. Is it intelligent? Is it able to do predictive power control? Is it able to deliver information about instantaneous power or voltage, power dissipation? If you think about a large data center, which may have hundreds and hundreds of racks of servers and thousands of servers when all added up, 20, 30, 40% of the energy consumed in that data center is heating and air conditioning. The air conditioning bill to cool down those racks is really quite substantial. It can be, again, 20, 30, 40% of the operating budget, and if you can control power better, not use power when it's not needed, you can really control your costs.
Well, but that's a very good point, but aren't there analog systems that can do those things? I mean, is it that critical to have a digital control system?
And there's really little opportunity to do it with a true pure play analog solution. You can control the power, you can deliver the power, but you really have no opportunity to either read back the data and get the telemetry, the instantaneous power, voltage, and current being used. You have no way to get that data into a digital system unless you've got some digital wrapper. I mean, it could be as simple as an analog to digital converter. It can be as sophisticated as an I2C bus or a lot of bus technologies that might be used.
Right. Well, I believe your current technology uses I2C bus for communications.
We do. I think we have really one of the most sophisticated, call it programmable power management ICs. Again, we deliver current and voltage, so it essentially is an analog solution, but it really is a digital controller with a completely flexible interface and an I2C bus that reads back to the host system what's going on with 4 outputs in a power supply, so that you can turn things on and off. You can consume power as necessary and turn things off when not necessary.
What's your system called?
Our system is 7724. It's XRP 7724. It was introduced in October and November of last year. It is fully programmable. There's a user interface that's completely software oriented. It's got a graphical user interface, single input, 4 outputs. And again, it's not only completely programmable, but it has the I2C bus, which reads back the telemetry data to the host.
Now, let's say I'm an engineer that would like to get involved in this, but I'm not sure exactly how or where. What would you suggest that how do they get started?
Depending on the supplier, and I'll tell you, we focused on ease of use and delivering a complete system. If you take one of our ICs, the 7724, and compare it to a solution that would be analog-oriented, analog switching regulators, and all the ancillary components necessary to make that system work, it would take 147 things on a board to take a 12-volt input and generate 4 DC outputs. Our solution is 33 discrete things on that board, so it's a factor of 4 or more or less in the way of complexity and bill of materials. And maybe more importantly is on your laptop computer, you put in our CD-ROM, fire up the software. What input voltage do you want? What output voltages do you want? What slew rate do you want to control? What margining? What tracking? All of those critical attributes of a power supply are basically programmed via your laptop.
And actually, when you think about it, even the reduction in components is a significant advance because that's less thermal, lower BOM, less real estate used up on the board.
And, those are all true, and maybe as important is reliability. The more components there are in a power supply, the more opportunity for failure, particularly in these systems which really dissipate a lot of heat. So between the flexibility, the programmability, the telemetry readback, and the ease of use, we think we have a very nice solution for next-generation power supply designs.
Excellent. So, how would we find out more? Is there a phone number or a website?
It's really easy, exar.com, EAXR, and you can't miss the programmable power products. It's very well highlighted on our website.
So exar.com.
Yes.
Excellent. Well, is there anything else that you wanted to talk about before we close out the episode?
No, I just encourage your readers and viewers here to go to our website. We have a broad line of analog mixed signal components, and we do some pretty sophisticated things for big data analytics as well.
Excellent. Well, thank you very much, Dennis. I appreciate Louis. I apologize. Thank you very much, Louis, for taking the time to be with us today. And I'd like to thank all of you out there in the audience for taking the time to be with us. We wouldn't be here without you. This is Alix Paultre for Paultre on Power. Have a great day.